Hello everyone. This is a data structure class. My name is JoonsooBae. So we have finished array in chapter 2, and also we also reviewed all of the C language class in freshman class. So I believe that you are all familiar with C language now, uh, and and today we will start a new chapter, chapter 3, about stack and queues. Okay, so this is a new data structure. Uh, uh, so we have to see what is the definition of a stack and queue, and what is the operation provided by this new data structure. And also after that we will study some application of stack and queues. Okay, first one is a stack. Okay, so I can define this stack as one word. It is last in, first out list. Okay, so stack is also one data structure. That means that this stack can hold many datas in stack. Okay, but the characteristic or operation in this data structure can be described as a LIFO, last in, first out. Okay, so the exact definition of a stack is an ordered list. That means that they hold many datas, many datas. Many data are stored in ordered list. Okay, but in this container, the data container, insertion and deletion of data are made at one end. Okay, so we can think that stack is one bucket to hold some items, like water can be stored in this bucket, and also some sand or anything can be stored in this bucket. Okay, but every time insertion and deletions are made at one end, this is one end. Okay, this end is called top. So this top of the bucket, every insertion and deletion must be happened in this position, in this location, top. Okay, so at the bottom it is at the first time it is empty bucket, empty stack. And next one data A is stored here, and next data B is stored here. Okay, so because there is only one end here, like here, so we must stack A data first. After that, B is stored here. And also at the same time B goes up to point B data. This top goes up to point B data. And then third data is inserted through the top. And C's location is above B. At the same time, top pointer, this is a pointer pointing to data C. Okay, so the top data will be pointed by this top pointers. Okay, and next one, another data D is inserted through the top. Okay, and top goes up one step, and last data E is stored here again, and the top will point to the top of the data. And also, if some data is removed, okay, all the deletion, all the removal happens at the top. Okay, so because E is the highest in the data in the stack, so E must be deleted from this stack. Okay, and the next candidate to be deleted is B. Okay, that is a stack. So in this figure, this bucket shape is stack. So stack is also one data structures. That means that it holds many data in it, but it has a special operation characteristic that insertion and the deletion happens always at the top. That is just a stack. Okay, so that is a definition of a stack, and many application of a stack we can find in every day. For example, this is a function call in C language. So every time in C language, if one function is called, then all of the function data is stored in the stack. This is a stack. So return address of one function and all the frame point will be stored in this stack. And if another function is called, then return address again, and all the frame point will be stored in the stack at these directions. And if this function is finished, then it will be deleted. And also this function is also returned. Okay, so if a new function is called, the stack will be growing. If a function is returned, that means that it is finished, then the stack will be shrinking. Okay, so that's typical example or application of a stack data structure in programming language, including C language. Okay. So in here, if this is a main function, and this main function will call a user-defined function fact, and the fact is recursive functions. This one. Okay. So if you execute this function, then how many function calls happens? First one is a main function, and second one is factorial 5. In this factorial 5, it will call factorial 4, and the factorial 4 will call factorial 3. Factorial 3 will call factorial 2, and 1 at the last. So how many function calls are called? So this one is a 1, 2, 3, 4, 5, 6 function calls will be executed. Okay, so how can you store all of the function call data? Okay, so you can use this stack. So what is stored at the bottom of this stack? Of course, it is main functions. And this main function will call factorial 5. And factorial 5 will call factorial 4. In this way, you can store all of the data. So factorial 1. Okay? And after that, this is a growing stage, and after that, f1 is called, it will return. Return will be shrinking of this stack. So f1 will be returned. That means that it will be deleted from this stack, and f2 will be deleted after that. In this way, it will go up or go down. So this is a shrinking to the bottoms. So that is function call. Example. Okay, this one. So now we can define stack in abstract data type. So the stack is a finite ordered list with 0 or more element. That is just simple definitions of a stack. But in operation, in function, it has its special characteristics. So among them, push operation is the most typical one. So push operation will insert item into top of the stack and return. Okay, this is insertion. Insertion will happen using push operations. Okay, and the next important operation is pop operations. So pop operation will remove the top data, remove and return the item on the top of the stack. That is pop operation in stack abstract dataset. Okay? Yes, that's the definition of a stack in abstract data type. Okay, so that abstract data type means that it is defined using pseudocode. It is not exact code. So pseudocode will be used in abstract data type. So push and the pop operation is implemented using just like a pseudocode. So if this one return else, it's similar to the C language, but it is not exact C language. It is a similar C language, so it is called pseudo code. Okay, so it is that is a abstract data type, and now this abstract data type can be implemented using array. So stack can be implemented using array in these chapters. Array. So array, we are very familiar with array. In C language, we have learned many methods or theory about array. Okay, so you must understand what is array in C language and how you can implement array applications. Okay, so here we can define array or stack in array using struct. Okay, this structure type dep structure is used. Okay, do you remember what is a type dep and what is a structure in C language? Yes, if you cannot remember it, you must review the C language again by watching the video I made it. Okay, and this type dep structure has int key member variable and other field. Okay, this other field is our data. Okay, I want to store some data in array using I want to store my data in stack implemented using array. Then my data must be defined in this field, even though it is commented, but actually it has our data stored at this point, at this location. And this structure name is element. So from now on, the element in this stack can be defined using this element data type because it is a type dep. Okay, so now we can use element as one user-defined type, data type. Okay, and the name is a stack. The size of the stack is max stack size. Okay, that means that I can store some data at most 100 size. So that is a maximum stack size. So that means that this stack may store 100 data. Okay, so can you guess how you can store student data? So I want to store student data in stacks. How can you define it? Okay, so type dep structure is the same, but in member variable key is the same, but you can define many attributes of this student. So you can define name as character name as 40. Okay, this is other field in this definitions. And also character student number, also 40 size, and integer age. Okay, this kind of attribute may be defined in this structure definitions, and this can be element. Okay, so you can store student data in stack if you define this element as include this student attribute here. Okay, yes, so this is called data structure part, and using this data structure you can implement some operations. So the first one is if is empty operation, and is full is trivial operations. So we can skip that it. But this one push is important operation in stack. So how can you implement it? Okay, so this parameter is item to be stored in this stack, or add an item to the global stack, and you must increase the top pointers. Okay, if you insert one data into stack, then top pointer must be increased by 1. So that is this one, plus operation in C language. And after that, the item will be stored, will be assigned to the top pointers. Okay, so this can be like this one. So the current tab is pointing here, but I want to insert new items here. Then you must increase the top pointers first and then insert one. So this one is first and this one is second one. So the order is important. That means that what can you rephrase this one lines? So this one line may be separated into 2 lines. Plus top is first line, and the second line is a stack. Top will be assigned as item. Yes. So these 2 lines were represented using these 1 lines. Okay. So plus is executed first. This is a first line. And then this assignment is happened. Okay. The order is important in here. And okay, that's all. So you must remember these lines. Very important. You cannot confuse the order of plus. Can you write top plus in this example? Okay, I want to explain here. If you implement using stack top plus or top plus, is this the right one? This one line may be write down 2 lines. So stack top equals item, and then top will be increased. Okay, so can you recognize what is the difference between these two and this one? So you must increase top first, and then at that moment this top will point to the empty one. In the empty one, they will insert this item. That's correct one. Okay, so you must be careful the location of a plus plus. Plus plus is before of a top index. Okay, let's go on to the pop. Pop is delete the data from the stack. Okay, delete and return the top element from the stack. Okay, that's the pop operation in stack. Okay, and here stack, return stack, and the top minus minus. Okay, so can you write down this one line into two lines? Here top first and and the top will be decreased. Is this a correct one? The meaning is here. Meaning is here. The meaning is a correct one, but actually if you meet return, then the function is finished before executing these lines. It's confusing, but the meaning is that you are returning top first and then decreasing top index by 1. Okay, so that's the also this is a important one. You must place minus minus after top index. If you decrease top index first, then you will return wrong element, not correct element. Okay, so you must be careful. Okay, that's all. Okay, now we can continue to the new data structure, queues. Okay, queue. Okay, queue is also very similar to the stack, but the operation in queue is different from stack. So the operation definition is first in, first out. In short, it is a FIFO rules. Okay, so queue follows this FIFO rules in data operations. Okay, so queue is also an ordered list in which insertion take place at one end and deletion will take place at the opposite end. Okay, so that means that they have different entry, different doors, and that means the queue has two doors. Okay, so stack has only one doors. Insertion and deletion will happen always at the top, but in queue data structure, insertion will happens at one end, deletion will happens at the other end. Okay, so this is also one pipe, not bucket. It is called pipe. To store some data. So the first data A is stored here then front index and the rear index. Okay, Q will use two index. One is a front index and the rear index. Okay, it's just like our waiting lines in a restaurant. Okay, so waiting line. If a new customer arrives at the restaurant, then they must wait, make a queue at the make a line at the rear, at the last customer. Okay, and the serving customer must goes at the front lines. Okay, so it is just like a waiting line. So queue is just like a waiting line in a restaurant. Okay, but if there is only one data, one customer, front index and the rear index will point at the same data. Okay, and then new data B is arrived. Also, you must think this is a pipe, not bucket. Bucket has a bottom, but pipe has open in other side, this side and this side. Okay, and now front will point to the A, rear will point to the B. So B is last one, A is front, first one. Okay, in this way you can store data A, B, C. Now 3 data is stored here, and D 4 data is stored here. So you just moving rear index to the last one, to the higher in this figure, because it is inserted only now. And then if one data is deleted or removed from this data set Q, then always deletion happens at the front index. Okay, so this A is returned and the front will move to point B here. Okay, so okay, you also still think that this is a pipe, not bucket. So this is a queue data structures. It's also very similar to the stack in the sense that it is storing some big data. Okay, you can store many data here. So for example, you can store 1,000 data, 1 million data. Any data can be stored in this queues. We can call it is a queue if the insertion happens at the rear and deletion happens at the front. That is a queue. Okay. For example, if job scheduling application, if one job is arrived, then J1 job will be stored in Q 0 here, and front is -1 and the rear will point to 0. So this one is 0. This index is 0 here. And second job, J2 is arrived here. Then J1 and J2 will be stored in the queue. And J3 is arrived here. 3 job is stored in this queue. Okay, this is a queue. So this one is rear. now, and this one is front. The current situation is here, and but if one job is deleted, then what job will be deleted? Then the first job will be deleted. J1 will be deleted, and then front will move to point this one. Okay, so 0 means this one, and the 2 is not changing at the moment. And another job 2 is deleted. Job 2 will be returned, and the front will be moved to the second element. So this one will represent this index 1 here. In this way, you can okay, this operation is FIFO rules. So every waiting line must keep FIFO rules. Otherwise, there is a cut the lines. Okay, so it is not etiquette to violate the FIFO rules in the waiting lines. So it is a queue. Okay, this is one typical example. So the abstract data type of queue can be defined as it is also the same finite ordered list with 0 or more elements. But in function or operation is different from stack. So this add queue operation is insert one data into queues. Okay, so this add queue will be will insert item at the rear and of the queue and the return queue. That is add queue. So add queue happens at the rear index, and the opposite one is that delete the queue. Okay, delete the queue will remove the data and return the item at front of queues. So front index will be moved in the delete queue operations. Okay, so that's the abstract data type of queue. So it is defined as a pseudocode. So you can implement this pseudocode into C language now. So you can think many design, many implementation of queues, but the simplest one is array, using array. So you can use array in implementing queues. So it is called a linear array. Linear array can be used to implement queues. So with two pointers, front and rear is pointers. The initial value of front and the rear is -1 at the same time. So front and the rear will point to the first and the last element in the pipe in the queue. So this is a pipe. Okay, how can you implement it? So the create the queue. Oh no, implement the array is also using a struct keyword here, element. It's the same as stack. So our data will be defined in these comment lines. Other field will include our data. It's the same as a stack. And this queue can be defined using user-defined data type, element. And the queue as size of a max queue size array. This is array. Okay, so in this part is called data structures. So the data structure used in this queue is array. So the array also uses element structures. So element structure array is a data structure used in this first implementations. And the initial value of a rear and front is -1, and is empty, is a full queue, is a trivial operation. But add queue is important, most important operations in queues. So add queue will add data in rear index, and the plus increment operation goes before of rear. Okay, so you can write down two lines which has the same meanings of this one lines. Yes, it's the same. So rear is increased first, and then the data will be stored at that positions. Okay, so you must be careful the location of a plus. And the other one is delete queue, is delete element from the queues at the front index. Front is one index here. So you will return queue plus front. Yes, you must increase front first. Front plus front, and then return queue front. Yes, it's the same meanings. So this front plus is has meanings here, because if initial value of a front is -1, that means that it will point to -1, meaningless data at the initial. Okay, so in order to return one data, then you must increase from the meaningless initial value -1 to zeros. 0 means the first element in the queues. Okay, so plus is important here. So you must be careful the sequence of increment or decrement operator in these implementations. Okay, so this is a first implementation using array. Okay, so can you think some problem over this implementation? Yes, because this implementation is linear, and the front and the rear index, front index and the rear index will go to the right, the one way movings from left to the right. Okay, that's the first implementation. Then at the end, the front goes to the end of this array. Okay, so it will make some errors here. That's the problems. So 2 pointers only increase, never decrease. So it eventually fall off to the right end of the array. So that will make errors. Okay, so that's problems. This problem can be solved by periodically moving the element to the left, But it is also some burdens. So you can think smarter implementations. So this is a second implementation using circular array, not linear array. So the first implementation was linear array. Second implementation is using circular array. Okay, so circular array also uses front and the rear index in the array, but it will make circular. Okay, so it will start from 0, 1, 2, 3, 4, 5. This is the end of the array, but after that it will use index 0 again. It will not make errors. Okay, so if you insert J1, J2, J3, then front will point to the 0 here, 0 here, and the rear will point to the 3. Okay, this is a circular array, and so if it will arrive at the max queue size, then it will go to 0 again. So if you have all of the elements are filled, that it is a full queues. So J1, J2, J3, J4, J5 is inserted. It becomes full. Front index 0 and the rear index 5. Okay, and then if some data is deleted, J1 and J2 and J3 are deleted, then rear will point to here, and rear, and after that J6 will be stored at the 0 point. J7, J8, and no. No, I was wrong here. So I deleted J1, J2, J3, J4. Then J4 will point to the front. And now J5, and after that J6 is stored here, J7 is stored here, J8 is stored here, J9 is also stored here, and this one is a rear index. Okay, so deletion happens first, deleting 4 jobs here, J1, J2, J3, J4. So rear, front index will point to the index 4 now. And after that, new job, J5, J6, J7, J8, J9 is inserted. Then rear index point to the 3. So rear becomes 3, front becomes 4. This is the final result of these operations. Okay, in this way, you can circle when you insert data and delete data. Okay, but anyway, if real delete happens more, then real increase fast than front, then it will make errors in the circular array also. But anyway, this circular array will solve the first implementation's problems. It does not need to move data to the left. Okay, it will just delete and insert the data using circular array. Okay, and if you implement queues using circular array, then a little modification is needed. So in other queue implementation, the first implementation was that queue plus real equals item. That was this one, but I said that this is 2 lines, real and q real equals item. Okay, in the plus real means that this is a real equals real plus 1. Okay, so this is very similar to the first implementation. The only difference, okay, real equals real plus 1 is here. Real equals real plus 1, and q real equals item, q real equals item. Yes, it's the same, but only different point is here. Do you remember what is this operator? Percent operator? Do you remember that? What is this percent operators? It is called modulo operators in C language. So it is called remainder operators. So if you make a division, real plus 1 by max queue size, then it will return only remainder of the division is percent operator in C language. Okay, it is called modulo operators. Okay, if you use modulo operator, then real values will get 0 if real plus 1 is equal to max queue size. Then the value becomes only zeros. Okay, so it will go back to the 0 point again. That will make some circle. So it is called a circular array. Okay, yes. And how about the delete queue? Delete queue also very similar to the first implementation, because at the first implementation, queue plus front. That was first implementation. But in here, front equals front plus 1 is the same as a plus plus increment operator, and return Q front is the same here. So only difference part is a percent max Q size. Okay, also it is called modulo operator here. So every operation in circular array uses modulo operators. In add Q and delete Q, both of them uses percent or modulo operators to make it circular. Okay, that's all about stack and queue definition and how stack and queues are implemented using structure and array. Okay, so you must understand it well. It is very important here. So next time we will go to amazing problems. Okay, thank you.